Hello there, Coach Travis with another pre-calculus video. So this is a tricky graph transformation problem. And what makes it tricky is that there's both a horizontal, I guess it's a horizontal stretch along with a horizontal shift. And whenever you have either a horizontal stretch or compression or a reflection, a horizontal reflection combined with a horizontal shift, that is always tricky. So I'm going to do this one kind of fast. So if you haven't watched my video about about reflections combined with horizontal shifts, that video details why I'm doing what I'm doing, why I'm going to solve this problem the way I'm going to solve it. So, all right. So again, the idea is I guess what's the point here? So yeah, just to remind everybody, the idea is we're given this graph, this dotted line, this dotted curve, and then that's f of x. And then we have the ability to move and stretch or shrink this solid curve down here, and we have to move and stretch or shrink this solid curve so that it gives us this version, that it gives us the graph of this transformed version of the original function. Okay. So the way I always recommend doing these problems, and this is whenever there's a number in front of the x, and that includes negative signs. Whenever there's a number or a negative sign in front of the x, I recommend that you solve the problem in the following way. Okay, so the idea is we're going to start with f of x, and what do we want to wind up with? We want to wind up with f of 1/3 x minus 1 plus 1. And so what I recommend always doing, whenever there's a number in front of the x, I think the easiest thing to do is to factor that number out. So what I mean is, okay, you can't factor it out of the function, because functions don't work that way. But you can at least factor it you can factor it as much as possible. So what I mean, you'll see what I mean when I write it down. So I can bring that 1/3, and then I can bring that 1/3 out. And then, so kind of the idea is I'm factoring the 1/3 out of both the x and the -1. So there'll be an x here. Okay, that makes sense because the 1/3 was getting multiplied by the x. And then there'll be a minus. Okay, but the tricky thing here is, okay, well, wait, it's not going to be a 1 anymore, because what I'm doing is I have to factor a 1/3 out of 1. And factoring means division. So if I have to divide 1 by a 1/3, and if you think about it for a second, 1 divided by 1/3 is 3. And you should always check your answer. So you might say, well, wait a minute, Travis, why is that a 3? Well, let's just check that it works. Are these two? Let me highlight them. Are these two things the same thing? Well, let's see. Well, the only difference is what happens if I distribute this 1/3. So 1/3 times x gives me 1/3 times x, and 1/3 times -3, sure enough, gives me a -1. So these are indeed exactly the same thing. So algebraically, I can work with either one of these. And this one I think will be easier. So let's so again, I guess the idea is I'm going to put I'll cross this out because I don't want to look at it anymore. That my real target my real target for this problem is this guy right here. But again, I want to emphasize this guy is the same thing as this guy. So it's the same thing. So if we target this thing, we'll get the same answer. Okay. So now let's think about how do we get from here to here. So what are the sequence of algebraic transformations I have to use to get from here to here? So well, let's see. Well, we need that 1/3. So the first transformation I'm going to do is 1/3 x. Oh, sorry, I forgot something. And then let's back up. Actually, wait. Let's back up for a minute. I got ahead of myself. So the idea is I'm starting with f of x. So let's see what that looks like. So if you start with f of x, there's the graph of f of x right there. So we start with the two graphs right on top of each other. And so we're looking at the graph of f of x. And so like we said, we want to get to this. So what we need to do, we need to get a 1/3 in there. So I need to multiply that x by 1/3. Okay, so then let's see. So what is that going to do graphically? So if you think about, well, what happens when you replace x by 1/3 x? So if you think back to your graph transformations, that's going to be a horizontal stretch by a factor of 3. So that means that all the x coordinates are going to get multiplied by 3. So in particular, this point right here, right now it has x coordinate 2. And if I multiply 2 by 3, I get 6. So if I want to draw the graph of this, the graph of this is now shown in that solid graph, because x turning into 1/3 x will be a horizontal stretch by a factor of 3. Okay, so now let's think. I still want to get to my target. I'm part of the way there, but the next thing I need is, that x needs to turn into an x minus 3. Oops, change colors. So f of 1/3, so if I replace that x by x minus 3, then, okay, if you think about graph transformations, replacing x by x minus 3 is going to be a shift to the right by 3. There's a lot of 3's in this problem. That's just a coincidence. So, all right, so I'm supposed to shift right by 3. So 1, 2, 3. I take the whole graph and I shift right by 3. Oh, that's kind of weird. This dot went off the screen. Hopefully that won't be a problem. All right, so we shifted the whole function right by 3. So now what I'm looking at in the picture is the graph of this function right here. Okay, and now I think there's just one more step. If I want to get from here to here, all I have to do is add the 1 to the outside. And adding 1 to the outside, we know, is a shift up by 1. So graphically, I'll take this graph and I'll move it up by 1. And now I think I'm done, because what I did algebraically on the right here is I took our original function and I transformed it into this expression, which is the same thing as what the question asked for. And we recorded in writing and on the graph what all of the graph transformations were. So let's check with the computer that we got this right. And sure enough, we did. So, all right, so the moral of these problems are tricky, but the way to avoid the common mistakes is to always factor. That if you have a number in front of the x and another number inside of the function, then I think the best thing to do is always factor that number out of both pieces. And then that'll allow you to much easier see what the correct graph transformations are going to be.